Alright, thanks for staying with me. This is going to be a mechanism walkthrough for a ketone and primary amine to an imine. Okay? Alright, so I want you guys to do this with me and try and guess my next move as I do this. And my amine is a little effed up, so I'm going to fix it first. Okay, so what do you think the first step is going to be, right? Okay, so because the reaction is acid catalyzed, you probably want to work with your acid first. And this is very similar to the acetal mechanism, so if you guys watched that video already, you guys will probably already know all the next moves. But yeah, so you're going to work with your acid first. Oh yeah, by the way, there's two mechanisms for this. There's an acid version and a base version. I'm just going to be doing the acid version to save time. But yeah, so because we're working with acid, we're going to protonate something, right? So we have two options. We can protonate the nitrogen here, or we can protonate the oxygen over here. Well, it's always the strongest acid and the strongest base reacts, and the strongest acid in this case is HCl, and the strongest base in this case is going to be oxygen. So it's going to be, and also it's the whole thing with you have to destabilize your carbonyl first for these type of reactions, and yeah. So don't know what that means. Check out my acetal video, but yeah. So you tack your HCl, the bond shifts over, gives it to the chlorine. So in this step here, we're going to keep track of our catalyst too. So we lost our catalyst in this step, so I'm just going to put a sad face. And then what you're going to get is this molecule over here, right? Okay, is anything missing here? Yeah, pause. Yeah, so what's missing here is a positive charge right here, because oxygen donated electrons to the hydrogen to form that bond. And also, oxygen is happy when it has 2 bonds, but now oxygen has 3 bonds, so not happy, has a positive charge. So what do we do from here to fix it? Well, you can resonate actually. You can do this. So this molecule is secretly half the time in this form, and also half the time in this form. And then you have a carbocation over here, right? Because the double bonds electrons went resonated up and left the carbon over here. But, so you don't want this form because it has a carbocation, which is very unstable, and it makes your molecule very reactive, it might blow up basically. Alright, so what happens is your primary amine, like the alcohol in my acetal video, it takes this opportunity and attacks. Acts like a nucleophile, right? And because it's in resonance, I'm just going to draw my arrows like this, because it's technically attacking one molecule. This molecule has like 2 forms. So when you attack either form, right, let's just work with this one here. The carbon now has 4 bonds, and it's getting a 5th bond right now. So we want to throw away a bond, and the bond that's easiest to throw away is the double bond, because you can just resonate it up and fix the positive charge, which is a very favorable type of thing to do. So then, from here, you're going to get this molecule. I'm going to move I'm having the amine appear on this side rather than down here because it's very cramped. So I'm just going to shift this carbon over, have my amine over here, and then my amine's like this, this, and then, right? Okay, is anything missing in this product right here? And the answer is yes. There should be a positive charge right here because the amine gave away an electron to form the bond with the carbon. Alright, so how do we fix this positive charge, right? We give the nitrogen electrons. Where does the electrons come from? Chances are it's going to be one of these hydrogens here. And you know that it's true because in your product, there's no hydrogens bonded to your nitrogen, right? And then how do we get the hydrogen to give up the electrons, right? Because this won't just happen. That can't just like happen like that and have a hydrogen pop out into space. That can't happen. So something has to motivate that step right there. And what that something is your catalyst. Here's where your catalyst comes into play and speeds up your reaction. So we lost HCl here, and we got a Cl- as a result. And that Cl- can perfectly take the proton, because that's what a base sort of does. And then it takes the proton, and then the electrons resonate, not resonate, sorry. Electrons just go to the nitrogen, and we fix the charge. And then also, because we're getting our catalyst back, I'm just going to put a happy face here, just so we can keep track of what's going on with our catalyst. Okay, so now you have this. Alright, nitrogen is nice and neutral. Let's see. Right? Okay. So So where do we go from here, right? Well, our goal is to create an imine, which is a nitrogen that's double bonded to the carbon, and the alcohol isn't even here in that picture. So you have to figure out a way to make our alcohol leave. Right now it's neutral, so it won't just like leave. It can't just do that. So what do we do, right? Well, the answer to that question is use your acid again. Whenever you get stuck in your mechanism, chances are you use your catalyst to help you out. So you use your HCl that was reformed in this step, and you have your alcohol attack it. This way you get this molecule over here. Okay, and then your alcohol now becomes basically like a H2O molecule. There's a positive charge on it. It's very unstable. And then, let's see. And then let's see, you have this. Okay, let's see, what's going on now? Lost my train of thought. Oh yeah, so you have an unstable molecule on inside your molecule. So this carbon's kind of like, he really wants to kick off that water molecule because it's really unstable and he doesn't want to be next to it. But this can't just happen, because if you do that, then you're going to get a carbocation, which is just a positive charge on a carbon. That's even more unstable. So instead of just kicking it off, we do, let's see, what do we do? We have one of the electron pairs on the nitrogen resonate down and form a double bond with the carbon. So we're basically forming these two bonds right now. So then, let's see, what do you get? Oh yeah, sorry, you formed the double bond. When you form the double bond, carbon's happy when he has 4 bonds, and right now he has 4 bonds already. So he's getting a 5th bond. So then he has to toss away a bond. Which bond does he toss away? The bond with the water molecule. Alright, and also we lost our catalyst here, so I'm just going to put a sad face. So we know that we need to get our catalyst back later in a later step in order to make sure we're doing the right mechanism, because you can't lose your catalyst or gain your catalyst. You get more of your catalyst. Alright, now because your water molecule left, you have a nitrogen with a double bond to the carbon, and then this molecule. Right? And then you still have a hydrogen over here. And then, let's see, yep. So, is there anything wrong with this product here? Take a look at it. The answer is yes. I'm missing a positive charge right here. Right? Because nitrogen had 3 bonds before, he gave away an electron to form a double bond. So he essentially lost electrons. So he's positive now. So yeah, how do we fix this now? And the answer is once again, your catalyst. You lost your catalyst here, you want to reform your catalyst. So right now you formed a chlorine ion again, or just the conjugate base of your acid, whatever. And it could basically pluck off that hydrogen and freeing up the electrons to the nitrogen. And then you're going to form basically HCl from here, which is your catalyst. So smiley face. Because we have our catalyst back, we can lose it, and then your product is formed, right? Take away the hydrogen, you get to your imine. And that's basically it. So let's see, let's just make sure we did the right mechanism. And how you do that is you can check if you created more catalyst or removed some catalyst. So you broke up your catalyst here, so one sad face, and then you created a catalyst. You got your catalyst back here, so those two cancel out. Oh, that's me. You lost your catalyst here. You lost the catalyst that you created right here, so this one is a sad face. But then you created it again in this step here, so cancels out, cancels out. Oh, that's me. But yeah, that's your product. And let's just take a second to kind of come up with a story for what happens in the mechanism. So as usual, like the acetal one, you destabilize your carbonyl first. You put on a positive charge on your carbonyl, so it's forced to want to resonate up, making it very vulnerable down here for a nucleophile like the amine to attack. Your amine attacks, you cancel out your charges, you fix all that stuff with your catalyst, and then you want to make your alcohol leave now because it's not your product. So what do you do to it? You turn it into a better leaving group by protonating it with the acid. And then once you protonate it, it turns into water, it wants to leave, But you can't just have it leave, or else you're going to get a carbocation. So you resonate the electrons down. So you don't get a carbocation. And then you get this. And then you can just fix that by using your whole catalyst stuff again. Okay? So hopefully you guys liked this way of, I guess, explaining mechanisms and thinking it through. I feel like if you think through your mechanisms this way and constantly ask yourself, like, why is this happening, or what's motivating this step, it'll help you a lot with memorizing the mechanisms. So yeah, hopefully you guys like this. If you liked it, please hit the like button down below. Share this with your friends if you felt it was helpful. And also, what else? If you want to keep getting updates for 1 and 2, post new videos, make sure you hit the subscribe button, which should be down here. But yeah, okay. Hope I helped. And if you want to see the mechanism video for the enamine, just stay tuned. See ya.